Greetings to all the viewers. The session is covering isoquinoline as the important compound, which is the part of heterocyclic chemistry. Earlier, we conducted various series of sessions based on heterocyclic compounds. In that continuation, we entered into the compound called isoquinoline. It is also regarded as a benzofused pyridine. In accordance with the IUPAC nomenclature, it is manifested as isoquinoline. Benzo-C-pyridine is the another alternative name. IUPAC stands for International Union for Pure and Applied Chemistry, and the session is powered by AI, artificial intelligence powered session it will be, and you can observe the compound over here. It is the kind of bicyclic fused system where benzene ring fused with the pyridine analog, and here the nitrogen taken at the position number 2. Here is the numbering provided in this heterocyclic compound where 1, 2, 3, 4 and followed by 5, 6, 7, 8 and the fused carbon atoms got ignored. And here is the three-dimensional representation for this isoquinoline molecule where nitrogen heteroatom taken the position at this corner. This is the way the intro regarding this isoquinoline is provided. Let me enter into the today's session. The agenda for the session will be introduction is provided to you and the synthetic strategy related with the isoquinoline and what could be the general properties provided for this isoquinoline molecule and the chemical reactivity towards various kind of reagents when we are going to add and eventually applications related with this compound in accordance with this therapeutic applications and medicinal chemistry applications as well. This is the way the session is going to conduct the kind of side headings whichever provided in this slide. Let me enter into the brief intro regarding this isoquinoline molecule. Isoquinoline is a kind of heterocyclic aromatic compound consisting benzopyridine framework, where benzene ring fused with the pyridine at a different position. Position number C here is the fusing is possible, and both are said to be isomers. Which compounds? One is quinoline and second is isoquinoline. Both are said to be positional isomers in specific. If nitrogen is occupying the position number 1, that is regarded as a quinoline. The position number 2, that is called isoquinoline, but physiological and biological activities of these two compounds are slightly distinct. Though they are positional isomers and positioning this nitrogen either at the position 1 or 2, there are various kind of distinctive factors which are identifying both the compounds in terms of their reactivity, in terms of their applications as well. This is the way it is the kind of isomer of quinoline and differing the nitrogen position in the fused ring system. Isoquinoline is found in many natural alkaloids and used in synthetic medicinal compounds and functional materials as well. If you observe the compound, here is the numbering provided. Benzene ring fused with the pyridine analog and three-dimensional representation is also provided. All black color lobes indicated for the carbon atoms and ash color balls indicated for the hydrogen atoms as well, and here is the nitrogen indicated with the blue color. It is the heteroatom. Whatever this ring system provided inside of the two 6-member ring systems are recorded for the delocalization of pi electrons in the entire ring carbon atoms. Rather, they are not static, always moving in among all the carbon atoms. That is the reason why electrons are indicated with the pi electron ring, right? And another three-dimensional representation is also provided without the bond, exact bonding between the carbon and hydrogens and nitrogens as well. This is the way the representation of heterocyclic ring system called isoquinoline is provided for the reference. Let me introduce the significant applications of this isoquinoline, why we are taking this compound as the consideration, and what is the specificity, what is the significance of this compound beyond various applications, right? Papaverine is a well-known compound. It is said to be alkaloid and which is extracted from Papaver somniferum tree, and here is the isoquinoline moiety inculcated into this kind of medicinal core compound, and you can observe the benzene ring is also accompanied with this kind of methoxy functionalities, and here is the another and the benzyl moiety is located at the position number 1, and again methoxy functionalities are located over there. This is about the medicinally important papaverine compound, and another alkaloid related with this isoquinoline is provided, which is said to be amitin. Amitin is also the kind of polyannular heterocyclic compound. You can observe the core moiety, which is indicated in the red in color. And here is the isoquinoline with the methoxy functional groups, and here is the CH2 bridging. alkyl group over there, and here saturated pyridine called piperidine is provided over there, and another heterocyclic ring system is also present. This is a kind of triannular fused system which is located upon this position number 1, right? So this is about the compound called amidine, and another polyannular system called morphine. Again, you can locate this isoquinoline moiety over there, and morphine is also kind of alkaloid which is extracted from the plant material again. Opium alkaloid it will be, and noscapine is also a kind of material. You can notice this benzene fused with this saturated ring system of pyridine, where in methyl group is also provided. This is also the kind of isoquinoline alkaloid, and here is another alkaloid provided where isoquinoline condensed with them. That is in contact with another benzene ring, and here is the five-member ring system with 2 oxygen atoms over the position number 1 and 3. This is the way much more alkaloids extracted from the nature. All these are having plant origin. And again, this continuation of the significance of this isoquinoline molecule, where tetrandrine as the compound, where you can notice this isoquinoline skeleton is provided, and in either isoquinoline, it is said to be a kind of dimer in between, and there are poly ether linkages are provided, which are working like bridges, and which are terminal ether linkages as well. This is said to be tetrandrine, and another isotetrandrine is also there. Again, it is a kind of dimer between the 2 isoquinoline moieties, and all these are kind of alkaloids only. And barbomunine, we will go with the potential applications of these compounds in the later slides, and this is also made by this isoquinoline skeleton, and which are condensed with this ether containing benzene rings, and here again isoquinoline nucleus is located. This is the way polyannular systems are alkaloids which extracted from the nature are composed by this isoquinoline nucleus at their core. And here is another compound, cannabine. Cannabine is the kind of compound where you can notice isoquinoline moieties. Again, it is the kind of dimer as you noticed in the above compounds. Here also you can notice the same, and there is a distinctive variation in the side chain. Side benzene ring is accompanied by here aldehydic functionality. Here hydroxyl is there, and ether bridging ligand, which is common in all these compounds what we are discussing here. And this is another dimer compound of isoquinoline, which is called a bargustanine. Bargustanine is also the kind of dimer of isoquinoline, where instead of 2 benzene rings, only 1 benzene ring is located for one isoquinoline moiety. So here barbidine is a kind of a medicinally important drug it will be, and it is also composed by this isoquinoline skeleton at its core. Simply, it is said to be a kind of dimer again. It is also bridged by this ether linkage. You can notice another dimer compound of this isoquinoline moiety called muraricin. Muraricin is also the kind of dimer, and an alkylated in benzylated isoquinoline is one moiety, and another isoquinoline is fused with methoxy functionalities, and both are bridged by again ether linkage. These many alkaloids which are resembling by the dimer linkages, and ether is the bridging ligand, bridging atom which is present over there, and these are said to be natural isoquinoline composed alkaloids. And some significant applications of these isoquinolines in the market we are going to discuss here. Papaverine is a kind of antispasmodic. Antispasmodic is nothing but the person who are suffering with severe stomach ache, that is spasmodic symptom it will be. You can clearly observe over there that is because of the infections in the stomach, infection in the kind of pancreatitis, or else any kind of digestive system disturbance that may cause the severe pain in the stomach. That is called uh, spasmodic symptoms, right? So papaverine is the kind of effective drug which able to curate this spasmodic symptoms, so that it is said to be antispasmodic agent. And another isoquinoline composed drug will be quinisocoin. Quinisocoin is the anesthetic agent which used to induce the calmness over there, and that is because of the that is because of the separation of the central nervous system and activity of the entire brain and the nervous system will be passed for some time, that used to induce the unconsciousness whenever the people or patient is supposed to go for any major surgeries or as any kind of curation during that time. It is a kind of medical induced unconsciousness because of this kind of drug where isoquinoline is taken at its core. And in there is a kind of isoquinoline fused with this pyrrole, and here is the benzene ring, which is in contact with this pyrrole ring. And this is also the kind of called a pyrulo-isoquinoline compound, dye paint compound. It is having the medicinal chemistry applications. It is working like a pigment coloring agent. And here anti-tumor agent is provided, which is composed by the isoquinoline core. And the tumor malignant kind of what cyst can be easily curated by means of this kind of isoquinoline based anti-cancer agents. And here is the kind of coordinate covalent complex where we are having dimeric isoquinoline moieties, and which are in complexation with the iridium. It is a transition metal, and here is another alkyl chain where you can notice alpha beta unsaturated ketone is located. All these are having coordinate covalent bonds with the metal iridium, where it is a kind of complex. You can notice phenyl isoquinoline iridium complex it will be, and that is having electrophosphorescent color display. Phosphorescence, fluorescence, both are the properties which comes under the photochemistry properties of the materials. Whenever light induced upon the material, now obviously it will glow, right? So that immediate glow of the material is said to be fluorescence. If we are stopping the source of light after some time, if glowing is possible and that continued for some time, is said to be phosphorescence. It is a delayed process. That kind of shining, that kind of coloring display is possible by means of materials whenever we are having the complexation with this isoquinoline moieties as a ligands with this iridium complex. This is why multiple applications were manifested in the slide. And let me provide the biological occurrence of the isoquinoline molecule. Isoquinoline is a kind of naturally occurring and synthetically viable, synthetically prepared compound as well. So that natural sources of isoquinoline are discussed over here. Isoquinoline alkaloids are widely distributed in the plant kingdom, particularly in the families such as Papaver. Already we gone through the papaverin plant, which is the poppy alkaloid, and the poppy family plants are able to extract this papaverin alkaloid where the isoquinoline core is present. And the Barbaridae is a Barbary family plant. It will be here. You can notice Barbary family, and whatever flowers manifested at the bottom are the part of Papaveraceae family flowers only. And here Barbary family flowers are provided, from which you are able to extract this isoquinoline alkaloid as well. And many spermaceae, moonseed family, it is a kind. So this is the way natural occurrence is possible. It is a kind of natural material as well, where we are having isoquinoline heterocyclic over there. Notable examples include opium poppy, Papaver somniferum. You already observed over there. These are the kind of materials which extracted from poppy family plant, only Papaver somniferum plant, from which you are able to extract the kind of isoquinoline alkaloid, which produces morphine and codeine as well. Morphine and codeine, this kind of papaverin, morphine, codeine are said to be a kind of analogs only. The certain kind of chemical transformation we can transform one compound into another. That's the reason why. All these are opium alkaloids only, and having slight distinct factors over there, chemical skeleton, and by means of chemical reaction, it is possible to interconvert these compounds, right? And Barbary species are available, and berberine is a kind of alkaloid extracted, which is composed by the isoquinoline at its skeletal core, and that Barbary plant flower is also provided for your reference. These many kind of natural sources are available to extract this isoquinoline molecule, and these plants have been used in the traditional medicine for the analgesic in order to relieve the pain, and antimicrobial. Any microbial induced diseases like bacterial diseases, viral infections, and fungal infections if the people are suffering with or else any kind of microorganism like unicellular organisms and platforms, worm related infections. So many kind of microbial activities will be destroyed by means of these kind of materials, where the isoquinoline is the important compound over there. Anti-inflammatory properties also incorporated into that. Inflammations can be better regulated by means of this one, and highlighting the therapeutic potential of isoquinoline derivatives. So many kind of medicinal applications are available for this isoquinoline compound. So that's the reason why the compound is said to be more significant in the market, and we are stressing for this isoquinoline discussion, right? So the session is going to continue with the nomenclature and the structure of isoquinoline. Nomenclature is provided as isoquinoline itself, and it is also alternatively regarded as benzocfusedpyridine, where the molecular formula is composed by 9 carbon atoms, 7 hydrogens and 1 nitrogen as well. If you observe, there are 9 carbon atoms are located and 7 hydrogens will be there, and one of the nitrogen is occupying the position number 2. It weighs 129.16 gram per mole. This is said to be its molecular weight. And structural formula, it consists of benzene ring and fusing with the pyridine ring are the position number 2. Where the nitrogen is located at the position 2 in the fuse system, numbering starts with the atom of the carbon. This is a kind of peculiarity. In general, we have to start with the numbering from the position of the heteroatom. In contrast to that, in a violation of that kind of rule, we are starting numbering from the carbon rather than the heteroatom. That is a peculiarity for this isoquinoline. It is a kind of positional isomer of quinoline molecule. Now we are going to discuss a detailed platform of the synthesis. How can we synthesize this isoquinoline in the laboratory viable pathways and industrial available pathways as well. And the synthetic protocols are provided with the various starting materials and reagents. Here, so many scientists worked upon this and they succeeded in the synthesis of this isoquinoline. Bichler-Niperovsky is the most prominent kind of synthetic platform in order to synthesize this isoquinoline in the laboratory chemicals. Bichler-Niperovsky synthesis is proceeded with the cyclization of beta-phenyl ethylamide derivatives. This will be the starting material for the synthesis of isoquinoline by means of Bichler-Niperovsky methodology. Starting material will be beta-phenyl ethylamide derivative, and it can be treated with phosphorus oxychloride. Phosphorus oxychloride is the reagent applied, and polyphosphoric acid is a kind of catalyst is promoting this reaction. Whenever phenyl ethylamine is taken as a starting material, phosphorus oxychloride is applied over there, and the dihydroisoquinoline is a kind of cyclized product available, and that further subjected to the kind of oxidation process and giving subsequent product called isoquinoline as the final one. A Bichler-Niperovsky synthesis is provided for a glance, and here is the amide linkage. Alpha, exactly adjacent position is said to be alpha, and beta position is occupied by the benzene ring. So that beta-phenyl amide it will be, and phosphorus oxychloride to be applied upon, so that initially we will achieve a kind of dihydro or isoquinoline. Later on, it will be oxidized, giving subsequent isoquinoline as the final product what we are expecting. In order to achieve this reaction, we have multiple steps over there, and entire reaction mechanism is provided for the better understanding, where phosphorus oxychloride is a kind of reagent applied over this beta-phenylamide. Beta-phenylamide having the kind of condition where the nitrogen is having lone pair of electrons taking part of this double bond formation. Subsequent oxygen is binding with the phosphorus, so that phosphorus containing double bond oxygen will delocalize the electrons towards the oxygen atom. This is the way a kind of new bonding between the carbon and new bonding between the kind of oxygen and phosphorus is generated. Whenever nitrogen is losing electrons, it is accompanied by the positive charge over the nitrogen atom, and here you can locate the double bond in between, so that imine linkage is originated, and oxygen is forming a new bond with the phosphorus atom, and where oxygen is taking the electrons from the double bond, so that oxygen is experiencing a negative charge later. This will go for the electronic cyclization by delocalizing the pi electrons from the benzene ring, though it is highly restricted for this utilizing the pi electrons towards the ring cyclization. But in order to attain the ultimate stability as the final product, this will participate in the ring cyclization. So the six-member ring will be originated in between the carbon and the carbon atom of this open chain, so that here the possibility will be a kind of six-member ring origination. uh, New six-member ring will be originated over there, so that pi bond whenever shifting, so that adjacent carbon is experiencing the positive charge, so immediately it will be stabilized by the delocalization. And finally, fused carbon atom is experiencing a positive charge will be allocated for the fused carbon atom. And there is a kind of a six-member ring system with nitrogen at the position number 2, and the position number 1 is located with already alkyl group is located over the carbon, and another side we are having oxygen and phosphorus, chloro, and double bond O are located, right? Subsequently, this will participate in the immediate ring closure, immediate aromatization reaction by means of chloride ion, whichever liberated during this step. During this step, what happens? Pi bond, this negative charge is participating in the pi bond formation, and subsequent removal of the chloride is required in order to satisfy the valency of the phosphorus. So that removed chlorine, whichever departed from this phosphorus, can take up this H positive, so that proton will be accepted by the chloride ion. Subsequently, bonded electrons are used to form a pi bond over there, so that aromatization is occurring. The aromatization giving rise to restoration of the benzene ring and the six-member ring system, and any other saturated ring system is located over there. It will further go for the departure of this phosphorus oxychloride moiety from this position number 1. Being it is heavier in nature, immediately it will be losing the entire phosphorus moiety, and whatever nitrogen hydrogen bonded electrons are present, these are participating in the pi bond formation, and the hydrogen whichever departing is accepted by the chloride ion again. That's the reason why there will be allocation of the new pi bond over there, and whichever hydrogen chloride are present. Being nitrogen is basic in nature, isoquinoline is slightly basic in nature because of the lone pair of electrons and the nitrogen in accordance with the Lewis concept, so that it able to form a kind of salt. And there is a kind of certain saturation over the position number 3 and 4. There is a kind of saturation you can observe. So we have to go for the further oxidation whenever oxidation is accomplished over this dihydroderivative of the isoquinoline salt, so that there is existence of new pi bond, so that entire molecule is having a kind of aromaticity, and here the kind of hydrochloride salt will be there. Hydrochloride salt will be originated. This is the way Bichler-Niperovsky is the most important synthesis for this isoquinoline, where phenyl ethylamine to be treated with phosphorus oxychloride, so the dihydroisoquinoline will be generated. That mechanism we've gone through, and further oxidation is required in order to accomplish this isoquinoline as the final product. Now, another named reaction is provided, Pomeranz phrase synthesis. In order to synthesize this isoquinoline, cyclization of benzaldehyde with amino acid aldehyde to be accomplished. The benzaldehyde is one of the starting material. Amino acid aldehyde is another starting material. Both the aldehyde compounds are supposed to be cyclized in such a manner, giving rise isoquinoline as the final product. Benzaldehyde, amino acid aldehyde, diethyl acetal to be taken as a starting materials in order to accomplish this Pomeranz price synthesis. Acid catalyst is required. Either hydrochloric acid or sulfuric acid are taken as the acid catalyst for this kind of synthetic protocol. Formation of imine intermediate taken in the reaction, and cyclization via acid-induced condensation is possible. Being the aldehydes are taken into the cyclization process, the reaction is proceeded with the condensation procedure itself. Benzaldehyde, amino acid, aldehyde, acetal to be treated with the acid condition, so that dihydroisoquinoline will be originated, that subsequent oxidation giving rise to isoquinoline as the target product. In order to achieve as the isoquinoline as the final product, we have to start with this benzaldehyde to be treated with this acetaldehyde, acetol. Amino acid aldehyde acetol. Amino acid aldehyde acetol. Acetaldehyde means what? The CHO will be there. Acetol means what? That to be transformed into a kind of ether linkages. Whenever that aldehyde to be treated with the 2 moles of ethyl alcohol, so that acetol formation. 1 mole, if we are treating hemiacetol, will be generated. If 2 moles of ethanol will be treated with the aldehyde compound, that giving rise to acetol as the a kind of compound. This is said to be OET upon the carbon is said to be acetol. Acetol is the derivative of that aldehyde only, and here is the amino linkage provided. This is one of the starting material to be subjected to condensation with this benzaldehyde. Obviously, NH2 will go with the condensation with the aldehyde by dehydration process. Water will be taken as the byproduct, and there will be a new linkage generated, which is called a skip base. Wherever amine to aldehyde condensation, that generates a skip base, which is a imine linkage, imine intermediate later. Whichever acetal functional group located over the terminal carbon atom will participate in a removal of OET functionality by subsequent delocalization of lone pair of electrons and the oxygen, giving rise to a double bond, so that one of the OET, ethoxy group, will be departed. Ethoxy group, when departed, here is the double bond originated between the oxygen and carbon atom, giving oxonium intermediate again. Obviously, benzene ring pi electrons will participate in the ring cyclization in order to accomplish this kind of 6-member ring system, fused 6-member ring system. There will be a back polarization of the electrons towards the oxygen atom, giving rise to a kind of 2 bicyclic ring system, 2 ring systems making a bicyclic ring system. In order to restore the benzene aromaticity, again subsequent H proton will be departed from this bridgehead carbon atom and giving rise to a new pi bond over there. Whenever new pi bond is generated, here we are having ethoxy. Here already being condensation is generating double bond in between the first and second position, so that here the double bond already existing. The only the requirement is new bond formation required in between the position number 3 and 4 only. In order to achieve this pi bond, in order to restore the aromaticity among the position 3 and 4, we need to remove hydrogen from the position number 3 and ethoxy from the position number 4, so that here the new double bond is originated by the departure of the ethanol as the byproduct. This is the way very simple systematic route map is provided in order to synthesize isoquinoline by means of Pomeranz-Price synthesis. Let me go with the Pictet-Spengler modified isoquinoline synthetic protocol, where primary amine is taken and to be treated with this aryl ethanol. Aryl moiety is located upon the carbon atom, which is the ethanol core. They are subjected to a kind of heating whenever heating is required. Obviously heating is required for the condensation reaction. Here is the amine, here is the aldehyde. They will go with the condensation generating a skip base. Skip base to be protonated by acid catalyzed conditions at the temperature 100 degrees centigrade, giving rise to a cyclized ring system. Thus, ring cyclization is accomplished by this pi bond electrons of the benzene ring and subsequent back polarization. And this is the way the ring cyclization, whichever possible, we already gone through in the earlier mechanism of the synthesis. And again, the 6-membered ring will be originated by acidified conditions over this imine linkage, right? So that will be a completely saturated one and to be applied with the palladium carbon. Palladium carbon is a kind of oxidizing agent, and the temperature required optimum will be 100 degrees centigrade. Catalytic hydrogenation will be the catalytic dehydrogenation will be accomplished, giving rise to isoquinoline as the final product. Isoquinoline as a final product, where we are having alkyl linkage over the position number 1. Position number 1 is located with this alkyl linkage. This is the way Pictet-Spengler modified isoquinoline synthesis is possible, right? The reaction is proceeded between the amine and aldehyde together, and acid catalyzed conditions are required. 100 degrees is the optimal temperature to be operated over this reaction, giving rise to isoquinoline as the final product. Pictet GAMS isoquinoline synthesis, it is a kind of somewhat different. Pictet Spengler reaction is different. Pictet GAMS reaction is different in order to synthesize this isoquinoline molecule. In order to accomplish a pictet GAMS reaction, cyclization of phenylacetaldehyde derivatives are required. Phenylacetaldehyde derivatives are taken as starting materials, and acid catalyzed conditions are applied. Either hydrochloric acid or sulfuric acid, strong acids, mineral acids are required in order to achieve this pictet GAMS isoquinoline synthesis. Cyclization reaction will be occurred under heating conditions and giving isoquinoline as the final product. In order to achieve this, again, we are starting with this primary amine, and where we are having alpha beta position hydroxyl group is located, which is said to be beta hydroxy beta phenylethylamine. It is said to be ethylamine, and acetyl chloride is the kind of reagent applied. Acetyl chloride will give rise to N-acylation. In acylation, nitrogen is acylated. Here, the acetyl group allocated to this amine. Later, phosphorus oxychloride. This is again resembling bachelor iperovsky again, and phosphorus oxychloride to be treated, and that able to dehydrate the molecule, and subsequent reaction dehydration giving ring cyclization giving rise to final product isoquinoline, where the reaction proceeded with this ketonic group will be transformed into enolic form again. Enolization is also accomplished. Enolic form will go with the dehydration. Simple hydrogen from this benzene ring and OH from this carbon atom will dehydrated. Water will be taken as a byproduct and giving rise to 1-methyl isoquinoline as the final product. This is the way isoquinoline synthesis is accomplished by pictet GAM modification synthesis, where primary amine can be treated with this acetyl chloride, so that we are going with the subsequent reactions with phosphorus oxychloride, and heating conditions to be applied, giving rise to methylated isoquinoline as a final product. Another methodology is also taken into the consideration, where we are taking aldehyde. Here it is the compound called cinnamaldehyde. It is the product generated by aldol condensation, everybody aware about. And cinnamaldehyde to be taken and treated with the hydroxylamine, another reagent to be applied. Aldehyde hydroxylamine obviously go with the condensation reaction by the removal of water molecule, giving this oxime. The intermediate generated here is said to be oxime. Oxime is having this terminal hydroxyl over there, and this will participate. This compound will participate in a kind of rearrangement. That molecule will go with the rearrangement within the molecule, giving rise to hydroxyl at the terminal carbon atom instead of nitrogen. After getting this kind of hydroxyl over the carbon atom will go with the dehydration under dehydrating agent phosphorus pentoxide, giving isoquinoline as the final unsubstituted product. In order to achieve this reaction, the starting material will be cinnamaldehyde to be condensed with this hydroxylamine, oxime intermediate, subsequent rearrangement and dehydration, giving isoquinoline as the final product. So we successfully accomplished the segment called the synthesis of isoquinoline. Let me enter into the physical properties of isoquinoline. What are the general properties allocated for this isoquinoline molecule? It looks like a pale yellow colored liquid or else a crystalline solid. It boils at the temperature of 243 and melts at the temperature of 26. 26 is a kind of room temperature only. Certain conditions like winter season, you may achieve the solid conditions. A crystalline solidity you can observe whenever the temperatures are lower than the room temperature. In general, the compound existing yellow colored liquid only, right? And here is the kind of skeleton provided for the isoquinoline, where numbering is allocated again, and the nitrogen is positioned at the position number 2. Solubility. being it is an aromatic compound and it's a kind of hydrocarbon in this and it is a kind of organic moiety, so it is obviously go for the solubility in the organic solvents like ethanol, ether, and benzene, and a very weak solubility in a water, being it is non-polar compound. Basicity. Nitrogen is available, which is characteristic for the basicity because of the lone pair of electrons in accordance with the Lewis concept, weaker base than the pyridine because electron withdrawing effect of the benzene ring. Minus A effect is operated by the benzene ring. That's the reason why nitrogen electron density is somewhat destroyed towards this benzene. That's the reason why basicity comparatively less in comparison to the pyridine, right? Let me introduce the chemical properties of the isoquinoline, what chemical reactivity it is possessing towards the various kind of reagents. As we already aware, it is the basic in nature and the weak base in general, and its pK value is characteristic for its basicity, and 5.4 is the value provided. Nitrogen lone pair of electrons are the responsibility for its basicity, and they are not taken the part of aromatic system and less basic in comparison to the pyridine because benzene ring is having minus affecting nature. That's the reason by dragging the electron density towards the benzene ring and creating the lesser electron density availability over the nitrogen atom. It forms salts with the acids. Whenever hydrochloric acid is supposed to be treated with this isoquinoline, that able to generate a kind of salt, which is isoquinolinium chloride salt, which is originated because of its basic nature. And the chemical reactivity, basicity comparison between the quinoline and isoquinoline, both are positional isomers only, but obviously isoquinoline is having higher basic nature strength in comparison to the quinoline. That is because nitrogen is direct contact with the benzene in case of quinoline in comparison to the isoquinoline. It is somewhat far away. That's the reason why minus affecting nature is somewhat less in comparison to the quinoline. This is the reason why basicity of isoquinoline will be higher than quinoline molecule. Then resonance structures are available, being it is aromatic in nature. Perfect aromatic benzene ring and the pyridine ring both are together aromatic in nature. That's the reason why multiple resonance structures are available, and even charge separation also possible because of the pi electron delocalization. These many possible canonical structures are allocated for this isoquinoline molecule. Electrophilic substitutions are characteristic reactions of most of the aromatic compounds, being it is aromatic in nature, and most specifically go with the electrophilic substitution because of the pi electron density over the benzene and pyridine in comparison. Benzene ring is higher electron density ring than the pyridine. So there is a compatibility factor of electrophilic substitution where we have to go for the substitution on the pyridine ring or else on the benzene ring. Obviously, electrophile will selectively go with the substitution over the benzene ring rather than the pyridine ring because of the electronegativity of the nitrogen atom that's destroying the electron density over the six-membered ring of pyridine. Benzene ring sufficiently electron rich in nature. Six atoms are contributing. That's the reason why the pi electron density is sufficiently contributed towards the electrophile. That's the reason why either position number 5 or else position number 8 are sufficiently substituted by the electrophile, which are most electron denser places in comparison to the other positions. Electrophilic substitution on the isoquinoline are less readily available in comparison to the benzene because of the electron deficity nature, that electron density on the benzene. So here is the benzene operated with electrophilic substitution, but in unsubstituted benzene is also performed with electrophilic substitution, but in comparison to the normal benzene, isoquinoline is somewhat lesser reactive towards the electrophilic substitution. That is because of the electron withdrawing nature of the nitrogen atom, which is dragging the electrons toward the nitrogen, so that electron density is somewhat destroyed, somewhat diminished over the benzene ring. That is the reason why the reactivity is somewhat slower. Electrophilic aromatic substitution reactions are manifested. Isoquinoline to be treated with the sulfuric acid and nitric acid together. Both are concentrated solutions of the acids, and 0 degrees are the optimal temperature to be operated. Cryogenic conditions are the requirement for this nitration reaction. The nitration mixture is operated over this isoquinoline. The suitable positions are 5th and 8th, so that a mixture of 2 nitro products will be generated. This is said to be 5 nitro isoquinoline. This is said to be 8 nitro isoquinoline as well. And bromination is accomplished by the Friedel-Crafts reagent Lewis acid AlCl3 aluminum trichloride to be applied the catalyst in order to activate this bromonium cation. Bromonium cation to be occupied at either, not either, at the position 5 and 8 together. That's the reason why we will achieve the mixture of 2 products instead of 1. Right. So this is the way nitration and bromination will be operated on the isoquinoline as a part of electrophilic substitution reactions. And there are certain reactions you can notice. Sulfonation is also accomplished by treating the concentrated sulfuric acid at the temperature 90 degrees centigrade. Sulfur trioxide is taken as the electrophile, being it is a neutral one, to be substituted at the position number 5 specifically, so that you can achieve 5 isoquinoline 5-sulfonic acid. Even alkyl halide without any Lewis acid is applied at the temperature 20 degrees centigrade. It is go with the enalkylation rather than the benzene ring alkylation. It is the kind of in substitution you can consider alkyl halide to be operated without any catalyst, so that enalkylation is the characteristic reaction. Whenever bromination is accomplished by the Lewis acid catalyst, that giving rise to broma at the position number 5. Nitration is accomplished by the nitrating mixture and giving rise to mixture of 5 and 8 nitro substituted products. And these are the kind of certain metals to be treated with the isoquinoline. These reactions are giving rise to a kind of reduction, a kind of partial reduction and complete reduction as well. Hydrogen in the presence of platinum catalyst transition metal to be applied catalytic hydrogenation in specific. That competing factors are there. Benzene ring is more susceptible for the reduction phase, so that here benzene ring will be saturated. Later, you can go with the further excessive quantity of platinum hydrogen to be operated continuously, so that entire ring system will be saturated, giving rise to a kind of totally saturated molecule. Complete reduction is a kind of condition you can achieve. Isoquinoline to be treated with diethyl aluminium hydride. Diethyl aluminium hydride is a catalyst applied over there that able to go for the partial reduction in specific. 1,2-dihydro isoquinoline is the final product. 1,2-dihydro isoquinoline will be achieved. Sodium metal dissolved in the ethanol solvent, that giving rise to entire pyridine ring will be saturated, giving rise to tetrahydro isoquinoline as the final product. All these are considered as reduction reactions only. All these are the part of reductions only. There are certain partial reductions are possible and complete reduction accomplished by the platinum catalyst. And let me go with the oxidation reactions of the isoquinoline. Isoquinoline to be treated with the neutral potassium permanganate solution, giving rise to phthalimide. Phthalimide is a kind of concised molecule. It is having 6-membered ring system as a heterocyclic ring, but here it is concised into 5-membered only, so that it is a ring contraction reaction in specific. And there are certain ketonic functionalities are located at the position 2 adjacent position with respect to the nitrogen, and this is said to be phthalimide. Phthalic acid is the kind of dicarboxylic acids at 1,2 position, and that is having amino linkage, that condensation over the position, that giving rise to phthalimide. This is a kind of neutral camino for oxidation, giving rise to ring contraction of this isoquinoline and the subsequent oxidation as well. Isoquinoline to be treated with caminophore only, but alkaline condition is the specificity applied over there, that able to cleave the ring system either. Heterocyclic ring is totally cleared, where the positions attached to this benzene ring will be transformed into carboxylic acid, giving rise to phthalic acid. And there is another possibility, wherever benzene ring totally destroyed, totally removed, totally oxidized, giving rise to the linkage positions as a subsequent carboxylic acid, which is said to be pyridine 4,5 dicarboxylic acid. This is the way mixture of two products, two probabilities are possible by fused ring system. Benzene will go with oxidation, pyridine will go with the oxidation as well. This is the way mixture of products will be accomplished by alkaline caminophore oxidation. Neutral caminophore oxidation will give rise to ring contraction process. These are said to be oxidation reactions of the isoquinoline molecule. Let me go with the nucleophilic substitution. Isoquinoline is susceptible for nucleophilic substitution as well, and most commonly observed nucleophilic substitution in heterocyclic compound will be a Chichi-Bobin reaction. Isoquinoline to be treated as soramide and aminated product will be achieved at the position number 1. Position number 1 is having electron deficit. Why? Because the electronegative nitrogen will destroy the electron density over the position 1. That's the reason why it is more susceptible for the nucleophilic substitution. Sodamide dissolved in the liquid ammonia to be treated, giving rise to a kind of nucleophile NH2 minus that is more prone to attach at the position number 1, being it is electron deficit in nature because of the electronegative nitrogen in the very adjacent position. So that one amino isoquinoline will be the expected product by this nucleophilic Chichi-Babin substitution reaction. Let me go with another nucleophilic substitution reaction where already we are having a chloro functionality over the position 1 to be treated with the alkaline sodium hydroxide solution under aqueous conditions. Aquated sodium hydroxide to be operated over the 1-chloro isoquinoline starting material. And the chloro is sufficiently replaced with this hydroxyl, giving rise to 1-hydroxyisoquinoline as the product that will participate in the ring tautomerism. And the enolic form will be transformed into a ketonic one, so that isoquinolinone formation is a ultimate product by this nucleophilic substitution by means of alkaline sodium hydroxide solution. Isoquinoline to be operated with an alkylation process, as we already aware about that one. So that isoquinoline to be treated with this benzyl bromide. Bismuthine oxidation will be operated by means of DMP. And NMP is taken as this is any kind of N-methyl cyclopyrrolidinone. So this is a kind of solvent applied over there. Air and room temperature are the optimal condition. 36 hours is required in order to accomplish this reaction at room temperature. And this DMP, Desmartin oxidizing agent will be a kind of iodo complex. It will be that to be operated over there. There are two probable reactions will be accomplished whenever alkyl halide is operated upon this isoquinoline. The obvious condition will be a kind of an alkylation you can observe. In addition to that one, DMP is a kind of Desmartin oxidizing agent. That's the reason why its in positions are supposed to be go with the oxidation, giving rise to two ketonic functionalities. There is another probability will be there. In addition to this first and third position, the fourth position is also go with this kind of oxidation if a DMP is taken as Martin oxidizing agent in the excessive quantity. There are possibilities for this kind of triketonic functionality as well. Most probably a kind of enalkylation is accomplished. In addition to enalkylation, there's Desmartin oxidation process giving rise to diketonic and triketonic respectively, depending upon the concentration of this oxidizing reagent. Let me go with the reaction with Grignard reagent. Grignard reagent is a kind of organometallic compound. It will be, I'm taking allyl magnesium bromide. Allyl magnesium bromide is a kind of Grignard reagent whenever applied over this isoquinoline in the solvent ether and rising the temperature to the higher, that able to delocalize the pi electrons towards the nitrogen. Being nitrogen is electronegative, accept the electrons towards that and getting a negative charge over there, and electrophilicity deficit of electrons experienced by the position number 1. That's the reason why a nucleophile alkyl group, magnesium attached alkyl group, is a negatively charged carbene and will accept the position 1, and C alkylation is a consequence over there. After the alkylation at the position number 1, the subsequent negative charge delocalization towards the ring, restoration of the aromaticity, and subsequent H positive removal under ammonium chloride catalyzed conditions, so that able to generate this restoration of the pyridine ring over there. And this allyl group will be occupying the position number 1 of this isoquinoline by means of Grignard alkylation reaction. So by means of this alkyl halide is able to go with the enalkylation. Wherever Grignard reagent is giving rise to C alkylation, there is a kind of distinctive alkylation process depending upon the kind of reagent applied. Grignard reagent giving rise to alkylation over the position number 1. And as a kind of lithiation reaction operated over the isoquinoline that able to react with the butyl lithium. Butyl lithium again is the example under organolithium, organometallic complex it will be. Isoquinoline to be treated with an butyl lithium so that hydrogen will be replaced with this butyl giving rise to butane as a byproduct and lithium occupying the position 1. Lithium-isoquinoline is taken as the expected product. This is called a lithiation. Lithium will be added. Lithium will be substituted. That's the reason why it is a kind of a lithiation process upon isoquinoline. By this, we successfully complete the entire chemical plethora of this isoquinoline molecule. Let me introduce the applications of the isoquinoline. What significant applications are marketed, are available in the market for the curation of various diseases, right? So here we are having dimethisoquin. Dimethisoquin is a kind of isoquinoline skeletal compound. It is the therapeutic agent made by this isoquinoline where we are having ether linkage over the position number 1 and lengthy butyl and butyl chain over the position number 3. Isoquinoline is taken as the effective pharmacophore within the molecule is having the property of anesthesia. Anesthetic agent which used to induce the unconsciousness bypassing the activity of the central nervous system and the brain, and that is taken as the anesthetic agent where the isoquinoline is taken as the core. The marketed drug name will be dimethisoquin. Dimethisoquin. Saquinavir is a kind of retroviral agent. It will be a very lengthy chain, complicated structure is allocated for this one. Saquinavir is a kind of is isoquinolyl moiety. Can you locate the isoquinoline? This is the quinoline. This is the quinoline actually. Here you can locate the isoquinoline, which is a completely saturated one, is having antiretroviral property. Papaverine is a kind of natural alkaloid where you can already aware most familiar compound taken into the consideration over there, and isoquinoline is the core compound located in the benzene ring. Benzyl group is located at the position number 1, and polymethoxy groups are present here. 2 methoxy groups over the isoquinoline and 2 methoxy are located for the benzene ring as well. And this is a very well-known vasodilator. Vasodilation is nothing but whenever blood is pumping through the veins, so that if blood vessels are very narrow, what happens? Pumping will becomes very difficult, and that will rise the blood pressure. High blood pressure caused by the kind of contraction of the vessels or else deposition of the cholesterol over there, right? So a kind of veins, whatever pumping the blood, which are very narrow in nature, very difficult to pass the blood through them. Whenever we are consuming a kind of a drug called papaverine potential vasodilator, so that vein size will be enlarged. Whenever size enlargement is possible, that used to pump the blood very conveniently, so that blood pressure will be regulated by means of this process, so that vasodilating agent, so heart related problems will be mitigated by consuming this papaverine drug, which is a natural alkaloid. And antihypertensive agents are also available where you can locate this isoquinoline at their core. So high blood pressure conditions will be mitigated by means of these drugs. Blood pressure conditions will be working by regulating the secretion of the adrenaline gland, and quinapril is the kind of effective therapeutic agent which is composed by the isoquinoline at its core. A vanilla spice will be there, vanilla essence, which is having isoquinoline composition. So from these are the kind of dry herbs from which you are able to extract this vanilla spice, which is extracted in the form of oil as well. It is a kind of food ingredient spice, so flavoring agent it will be. And here we are having another well-known compound composed by this isoquinoline at its core, that is called noscapine. Noscapine is the kind of alkaloid which is composed by this isoquinoline having antitussive property. Antitussive is nothing but the people who are suffering with the cough conditions. Cough condition, it is a kind of respiratory syndrome that can be better treated by means of noscapine drug. And here we are having berberine. Berberine is the kind of traded drug which is effective for the curation of inflammation. The people who are suffering with this inflammations like pains with the swelling and injuries, that condition will give the severe pain, right? That kind of conditions will be effectively curated by means of the drug called berberine. Anti-cancer agents also valuable. It is evidenced that so many isoquinoline moieties are having this curation towards the tumor. So that these are the examples covering isoquinoline moieties having this benzyl ring or benzyl moiety over the position number 1, and the methoxy functionalities are the common ingredients located over there. They are having the property of the malignant tumor curation. Isoquinoline also having the material chemistry application. So many colors will be induced by means of this kind of isoquinoline. The dyes whichever imparting the colors are manifested in this circle, and these are said to be chromophores. Chromophore is responsible to induce the color. Oxochrome is responsible to intensify the color. That's the reason why the circled part is responsible to induce the color called chromophore. The chromophore property is also located for this isoquinoline. You can observe, you can notice the isoquinoline core at its circle. So which is a kind of dyeing agent. By this, we successfully accomplished the entire session where various natural origins for the isoquinoline were manifested, and synthetic laboratory pathways are discussed in detail, and later we entered into the chemical properties of that one, and in what way we can apply the compounds in various fields. Entire discussion is provided. Hopefully the session is very much helpful for the viewers who are aspiring for the research, scholars and academicians, and those who are in the kind of a new drugs invention in the field of pharmacy, in the field of medicinal chemistry applications like dyes and any other materials. Always the research is never ending. That's the reason why the kind of isoquinoline is fetching for the scientists who are in the field of that kind of research to invent the new compound, new auxiliaries, new applications, new plethora of curatives, new plethora of materials in order to introduce. So the session is very much helpful for them. And in addition, the people who are serious about the competitive exams and entrance examinations as well, this will give much more valuable information. And the session conducted by Dr. Kavita Kottireddy Kota. Hopefully, this session is very informative towards the aspirants. Thank you very much for your listening.